Section 12.2, day number 3. In example 1, we're going to evaluate each limit. The problems on your assignment for 12.2 day number 3 are going to have those directions. They are similar to what we did on day 2. For day 2, we were using direct substitution if possible. But if it was not possible, we just needed to state why. So if we were to look at this and evaluate this limit, we might try direct substitution, but if we do take 3 and we substitute it into the bottom there, we do end up with 3 minus 3, or 0 on the bottom, and we can't divide by 0. That gives us an error. If the directions are like the ones on day 2, we would just say you can't divide by 0 and we would be done. But what I did mention in that day 2 assignment is that just because we can't use direct substitution doesn't mean that the limit does not exist. It just means we can't use direct substitution. So what 12.2 day 3 is going to have us do is use direct substitution, but when we try to evaluate using direct substitution, it won't work. So we need a different method. And instead of just writing down that it's not possible, we're going to look at what some of these other methods are. So if I go through and try direct substitution, if I take 3 and I substitute that in for the x's in both the top and the bottom, we end up with that substitution. On the top we have 3 squared minus 3 minus 6. If we evaluate that, 3 squared is 9, minus 3 is 6, minus 6 is 0. And then on the bottom, 3 minus 3, which is also 0. That fraction, 0 over 0, that is something called indeterminate form. In indeterminate form, what that means is we have tried direct substitution, we've tried evaluating it the way that it is, and it does not work. So we need another method. We can't use direct substitution on this problem. So what I'm going to do instead is I'm going to go through and take the limit as x approaches 3 of our original and do something a little different with it. If you have a rational function like we do here, a polynomial on the top and a polynomial on the bottom, and when you do your direct substitution, you get 0 over 0, what that means is there is a common factor in the top and in the bottom. If we do some factoring, we should be able to cancel that out. So what we need to do is factor the top and factor the bottom, and then we should look on the top and the bottom and we should have a matching factor that will cancel out. So let me do a little bit of work off to the side here for a second, just to review. I'm going to erase this in just a second so that it's not in my way, but I just wanted to review with you some factoring. We haven't done that in a little while. X squared minus x minus 6. That's that add multiply method. Our first step would be to see if there is a common factor, and there's not here. And then with 3 terms, we'd want to go through and do that add multiply method. Again, you can set this up with an x, do it in your head. You don't have to show me any work on this step at all, but just to review a little bit. We're looking for 2 numbers that add to be the coefficient of this middle term, which is a -1, and multiply to be the lead coefficient, which is this invisible 1 in front of the x squared, times that last term, and 1 times a -6 is -6. If I can find 2 numbers that fit that pattern, then this is factorable. There are 2 numbers. They are -3 and 2. And best of all, because we do have a 1x squared, I can use our shortcut. So that is going to factor into an x minus 3 and an x plus 2. Again, you can completely go through and do that step in your head. You don't have to show me any work on that. But if you need to, off to the side, you could do a little scratch work to do that factoring. So our numerator, the top part of our fraction, factors as an x minus 3 and an x plus 2. We also want to factor the bottom part of that fraction. The bottom part of the fraction, well, there's no common factors, and it doesn't fit any of the patterns that we have for factoring. So this is not factorable. And if I get something that's not factorable in a rational function, I tend to put that in parentheses just to remind myself I can't cancel out just the x or the 3. If you have addition or subtraction, you have to cancel the whole factor or not at all. Now that I have this factored, I should look top and bottom and see if there's anything there that we can cancel out. Outside of our parentheses, we do not have any addition or subtraction, so I can cancel out that entire x minus 3 on the top and the x minus 3 on the bottom. So what we end up with is the limit as x approaches 3, and if we cancel all of that out, we have an x plus 2 factor remaining on the top. Everything canceled out of the bottom, so there's just a 1 down there. We wouldn't have to put that 1 on the bottom, but it doesn't hurt to have it in there either. Now I'm going to do direct substitution again, and if I plug in our 3 into the top, we have a 3 plus 2 on the top, which gives us 5 over 1, or just 5. So our final answer for that problem is 5. In the directions for today's assignments, you're going to be evaluating the limit. You should try direct substitution to start with. It will give you indeterminate form. And if you have a rational function, you should factor the top and bottom and then get your common factor to cancel and try that. As you go through and do these problems, they are all going to give you 0 over 0 when you do direct substitution. So the amount of work that I actually need to see on this would be just what I have here in green. You do not need to show me that step where you did direct substitution and you got that indeterminate form. You can just jump right in and give me what I have here in green.